So a little about me for those who don't know me. I write software. I write in, obviously, Swift, Go, TypeScript, and because I do a little bit of machine learning, a little Python. That's my office. I work from home. My commute is about 15, 30 seconds from the kitchen to the studio / office / pain cave for anybody who rides indoors. I play music, that's my band. And I ride mountain bikes. Although sometimes I do fall off. That was 22 stitches. And a little bit of time in hospital. All right, SwiftTEA UI. I can't take credit for the SwiftTEA part. Matt, when we were talking about titles, I had some lame ass title. And Matt said this, and I said, that rocks. If I swear, I apologise early. All right, I've given a little talk about this once before about Redux. How many people here are familiar with the Elm architecture? A lot more people than I would expect. Basically, the Elm architecture can be boiled down to this. It's a model, and a message is an input to a function, a model to some commands as an output. That's the entire architecture. The entire thing. That's all you really have to think about, those three things. Models, that's your state. Messages, things that have happened. Commands, side effects you want to perform. Pretty straightforward. T versus Flux or Redux. You hear Redux come up a lot, especially since we've gone to SwiftUI. Redux is a sort of implementation of the Elm architecture. Flux, sort of implementation of the Elm architecture for React and other frameworks. But it lacks one crucial thing. It's model message to model. Okay? It has no explicit side effect handling. There are things like Redux Thunk that go and throw some asynchronous processing in front of the processing of your messages. But the framework itself has no direct handling of side effects. Does anyone know what I mean by side effect? Anybody not sure? All right. So that's your overview of Elm and the things that we'll talk about SwiftTEA UI. Now I have a quick demo. And if we're all really, really lucky. I don't know how to, I can't seem to get my, how do I, mirror displays. Okay. Not a lot of tab going on here. Sorry guys, just got to figure out how to actually switch screens. Exit. Now I can switch screens. All right. So this is a little quote of the day application. It goes off, hits a quote of the day service, and pulls an image down. Right? It does do some caching. So right now, a lot of this is cached. So we've got some asynchronous thing. Let's just reset the cache and see what happens. And we'll run it again, and if we're all lucky, we get a spinny, we get the list of things. When I go in, look at my funny quote of the day. Let's load that one pretty quick. There was a spinny there, I promise. Except the network here is better than my one at home, actually. Here on this one's got a really big picture. And all right, there we go. So that's the application I'm going to talk about today. It's fairly straightforward, but it's got a lot of the things we have to deal with every day. It's got a lot of asynchronous processing, it's got remote resources, it's got API lookups. All those things we have to deal with most of the time. All right. So, last time I was here, I was talking about Redux, which is my wee version of Redux. It actually started off as a wee version of Redux, and then I hated Redux and made it into a wee version of Elm, but I didn't want to make it wee Elm, so it's very much the Elm architecture with an asterisk on the output model. And the asterisk is, I'll tell you about in a second. So your model is, and this is the model from this application, it's a straight struct. In this case, it's codable. Some little framework magic means that if the thing's codable, you'll get automatic persistence with Redux, but that's not here or there. But that's my basic model. So I've got, let's see, I've got some categories, some quotes, and a cache. Everything above there just defines those things. I've got a series of messages. So these are the things that have changed. Categories are loading. Categories are loading has failed. It happens. Categories are loaded, etc., etc. And I have some handlers. And this is just takes a message and applies the information to the state. And here's where that state asterisk comes in. You notice I'm not reassigning, even though that was a struct, I'm not reassigning. State is passed as an inout variable. And that just makes the ergonomics, as I explained, a little bit easier and cleaner to work with. You don't have to constantly copy your let var to a var that you're going to mutate and split out. You're going to mutate this thing anyway. We just do that. And to build up your list of handlers for a message, I've got a little custom operator. People do or don't like those, but you can also use dot append, I think, something like that. It's just a method of combining. All right, so let's talk about the ergonomics of that. This is what I just spoke about. State is an inout parameter. And the reason for that is that my first version of that, state wasn't an inout parameter, and you ended up with a lot of boilerplate, which was basically copying the state to a variable that you can mutate and returning that variable. You get rid of that. So that cleans that aspect up. KeyPaths. KeyPaths make accessing parts of your model much easier. So because I'm all statically typed, I can put a keypath in there, it compiles, it knows where that is, and this is going to pull out that piece of information from the model and apply this function. There's a little bit of boilerplate there just to make sure I'm dealing with the right type of message. Typealias. There's a lot of generics in this stuff because model is generic, message is generic, command is generic. And if you've got to type that bottom line every frickin' time you want to do something, it's just a nightmare. But typealias take care of that and we just end up with an application program, message handler, a reducer. The only difference between a message handler and a reducer, again, is a small ergonomics thing. A message handler, a reducer is a message handler that produces basically a none as its command. Right? So it's not going to have any side effects. That's all. So it's a reducer it's a message handler without side effects. It just, again, makes some of the ergonomics a little bit easier. And so what that ends up with is a lot less noise. So when you're using a reducer, you're basically, in this case, all the data I need is the name of the message, and I can say, hey, this state, which is the categories from my model, is loading. SwiftUI, as Matt so kindly said, is basically declarative views and reactive state. Right? So it's we had earlier about RX, reactive state, and rather than having imperative views, which is a lot of internal stuff going on that you don't see, everything happens at the top level. And SwiftTEA UI is Redux plus SwiftUI. It is only 4 components, and they're really quite straightforward components. A store, a dispatcher, a store container, and a state container. A store, and that's it, the entire implementation, basically tracks and publishes program updates. So a Redux program is producing changes. This just tracks and updates them and puts them into a SwiftUI bindable world. Right? That's why we have observable and published. And it always delivers on main, which is kind of handy. A dispatcher is a way of you sending changes back to the program. So you can send messages or commands, things that are going to have side effects, things that have happened. And containers. Containers separate the views from the state location. And this is starts to become a really powerful concept. When your view has no idea where it's getting its state from, it makes it much more easy to reason about because all of the state is local. Everything you need to know about that thing's changes is local. A store container, again, these are the full implementations, by the way, so this is not a lot of code. Shares the store and the dispatcher. Basically puts them into that wonderful thing we have, which in the Redux world is called a context object, or the React world is called a context object. We call them environment objects. It's basically an object, a container that sits in your view hierarchy that you can randomly go and get data from. It's like a global variable for that point in the view hierarchy. It does make things a little convenient. State container, and again, it's a fairly small implementation. Just as a side note, I tend not to use protocols. And my biggest reason for not using protocols is type aliases. Trying to combine a protocol that has type alias and another protocol that has a type alias it's hell. You can't return things with type aliases. So it's much easier to use witness structs, which is what your protocols get compiled to anyway. So basically, there's fields that have functions in them. So the state container captures the store and the dispatcher. You provided a method to read the state to some other type that you want in your view. A render function that takes that captured state, a dispatcher, and renders your view. And which you can see ends up down here as this signature here. And again, let's come back to ergonomics. Everything I'm trying to do here is trying to make things simple to reason about. And this is where, again, KeyPaths come in. And if you've ever used zip or something like that in Swift or Combine now, you end up with these massively overloaded things with KeyPaths or multiple variables. So you have about 50 of these variants for how many parameters you want to be able to deal with. But by doing this, and type aliases again, it makes accessing this information a little bit easier. So why? So there are a number of Flux implementations appearing for SwiftUI right now. And they all do exactly what Redux does. Your store and your dispatching are bound. They are one concern. So you're holding of your information that you are pushing down, and the information you want to travel up is bundled up into one concern. They call it a store. I separate these out, and it's can you think of why I might separate these out? Can I ask a question, by the way? I know the whole question thing was, but why would I separate these out? Other than for solid principles. Let's just forget the solid principles. Let's practical. We'll keep going and see if someone can answer a little bit. So let's talk about some patterns that I tend to use with this stuff. The container, the view model still exists because you've got to take your domain information, get it ready for presentation, etc., and a body view. Again, this is a very common pattern in modern versions of React applications. A container simply grabs the data and makes it available to the view model and thus the view, right? Because we're going to wrap everything up. It has no other responsibility than that. It extracts the data from the store container, it gets the dispatcher, and then it sets up the view model. The view model is your use case information, right? So this is where I want to do things. It's going to bind my ins and my outs. And the body is now a really simple view class. No logic in it other than displaying things. Right? So it's going to receive the model, it's going to read the categories out of the model, and this one doesn't use the refresh here, but that's all right. The refresh is actually used internally. Which comes down to another tiny little thing. When I was doing this application, I had this bug. And I would put the screen up, and the quote would load, and the image wouldn't. And I'd go back, and I'd go forward, and the quote would load, and the image wouldn't. On appear is very smart. Even if you're rebuilding the entire view, if it's had that view up there, it doesn't fire the on appear again. So don't use on appear for doing multi-stage refreshes, which is what I had going on. What you can notice from that is that there is not an observed object or observable object in sight. So all that application, so we see a lot about observed object, observable objects now coming out of the SwiftTEA UI space. They're all about dealing with local state and knowing where your state is. The whole premise of this is to detach location of state from use of state. At state, though, is still very useful, mostly in your view models, because you're still going to get information out of controls. I'm going to get some text typed. I've got to stick that somewhere before I commit it via a message. You might commit it as soon as it's typed, send a message as soon as it's typed, because you can observe it internally, or you might just wait until everything's done and they hit back on the screen and then actually commit it as a message. Choice is up to you, but you still need a way of capturing input at the view level, and that's what at state is for. It's very local, and it exists in your view model alone. Second pattern is async operations are commands. Right? Here we have the background for the second screen. Has a resource panel. All the resource panel is a view that understands the 4 states of a resource. It's in placeholder state, it's loading, it's failed to load, or it's got the data, right? And depending on that stuff, it's going to call this internal view. So when it's got the data, it'll call this internal view. And you can do some customization on it as far as, what spinner you want to use, etc. But in essence, when it has data, it shows the internal view. Otherwise, it shows the placeholder or the spinner, etc. This image doesn't try and load itself. It's just a URL that comes in, doesn't try and load itself. Inside of the view model, I have a refresh background. So it really quickly checks, hey, is the image in the state? So I've got the image for this quote. No, it's a nil, because it's going to be nil if I come back from there. It's just a dictionary. Go and get it for me. Execute, send this command. A command is a side effect / asynchronous operation. Right? So it's going to go off and do something with the external world. If not, it's going to double check whether it's failed or placeholder. And again, if it's failed or placeholder, so I've got a failed or a placeholder in that slot, I'm going to say, well, actually, I want to try again. I want to go grab it. Otherwise, I've got an image or it's loading. I don't really care. And then this is the container, and it just binds information. So it's out of the application state, it's grabbing the quotes and the cache of images. It's converting that to the props. There's the dispatcher, and then I build my view body, which has my view model. Category, quotes, images, dispatcher. Pulling, by the way, I really like to pull those out as like just variables rather than 0 and 1. Swift compiler hates when you start having functions nested in functions and nested in functions, and will just start giving you, oh no, and gives you type check errors. If you try and pull those out above, you'll get type check errors, and you've got to go and put the full frickin' signature on things. So I live with that. It's just drives me. Do I go forward then or backwards? Right, and now the command. And the command actually goes off and loads the image. When it starts, it publishes unloading as a message. This has happened. Tells the task to resume. Task comes through, bit of error handling here. Oh look, couldn't decode it. Send the image failed message. Send the image load message. Done. And then those events come through, those messages, message handlers. There used to be event handlers. They're called message handlers. I just keep using the wrong name. And again, a really straightforward thing. It's just going to grab the message, stick it into the. So again, I'm using a KeyPath to get at cache images. I've got the current state and the message. From the enum, I extract the actual data from the loaded, and I go and shove that in the location. That runs, everything propagates. There's a subtle implementation anti-pattern inside of that method. Commands should interact with the outside world via an environment. One of the things from my last talk I spoke about is that commands are given two pieces of information. They are given an environment, which is an arbitrary structure of your thing, which is where you put anything that's a service going to perform a side effect. And it's given a way to publish messages. That's it. By doing this, I've made this really hard to test, because I've gone and got a URL session directly inside of there. So me testing that, I can't drop in, just have an environment which is an image loader and grab it and make it work. But normally what you do is just replace that with an image loader service. You grab out of that underscore parameter at the top there, next to publish, and that's your environment, and then you grab that from the environment, tell it to do its thing, get a result back, and then publish the messages. So, a whirlwind tour of Swift. There is not much to this, but it does change the way you start to think about things. Architecture for me is about making it easy for me to do the right thing. Right? That's all I care about. I want to be able to write applications. I want to be able to write them quickly. I want to be able to write them correctly. The less time I have to spend debugging and figuring out what the hell I've done, the more productive I am. I can concentrate on features and not on defects. By isolating side effects, by having your view completely driven from a push-down state, by having containers and state captures that are all type safe without the need for protocols. Again, very few protocols were heard in this presentation. There's about, I think in that application there's maybe 2 protocols. One is application message, which is a marker protocol, just so I can pass all the different enums I use in as messages. That might be it. In Redux itself, I don't think there's a single protocol. There are a lot of witness structs. So hopefully this makes you try to kind of think about how simple applications can be, especially views of applications, with Swift UI and something delivering its state. Controlling your side effects via commands, so something's going to happen to an outside world. All of this stuff is super testable because everything is just a set of inputs and outputs. By controlling everything that's going to change your model. Every possible way of changing your model is captured because you have an event or a message for every possible change you can do on your model. Right? And I have a question slide, but I'm not allowed to ask. You're not allowed to ask. Start doing But you can catch up with me later. The code for this application will be up on GitHub tomorrow. I didn't get time to push it out later. So if you're interested in how this actually works and you want to dig into it deeper, the resource thing, I've seen a bunch of image loaders for Swift UI, and they've all got internal state, and they're doing this, and they're calling out here, and it's like, just have a command to publisher and have an event that's loaded. And resource is a really handy little frickin' construct, because we've got all these things that are asynchronous, and we don't know the current state of. We're waiting for them to load. This captures that concept completely. Right? I'm waiting for some data. I've got a resource. Away I go. Thank you.